Hi everybody! In this video we're going to be taking a closer look at the recursive sequences and looking at day 2 of this lesson set. What I'd like for you to do is to please pause this video and do the do now, which is given f of 1 is equal to 13 and f of n is equal to f of n minus 1 minus 6, find f of 4. If you recall from the first day of our recursive sequences lesson, it says that f of 1 is the first term in our sequence. And if we're trying to find f of 4, we need to repeat this function multiple times until we can find the fourth term in our sequence. So according to our rule, to find the term that we're looking for, we're going to be taking our previous term and subtracting 6 from it. So our previous term is 13. So I'll say, okay, let's take this 13 and we're going to subtract 6 from it. 13 minus 6 is 7. So 7 is our value for f of 2. To find f of 3, we're going to take that value, 7, and subtract 6 from it. 7 minus 6 is 1. That means our f of 3 value is 1. And then finally, we're going to take 1 and subtract 6 from it. 1 minus 6 is negative 5. That means f of 4 is equal to negative 5. So you can see here, it's a chain reaction type of problem. Now let's take a look at the notes for today. The first thing that we're going to explore is writing the recursive rule given a list of numbers. To do this, what we need to do is first identify if the rule is arithmetic, geometric, or neither. The way we do that is we look to see what type of pattern is happening with the numbers. Do we keep adding or subtracting a certain number, or do we keep multiplying by a number? Or do neither of those things work? Maybe it's a little bit more complicated. Then we also want to find out what the first term is of the sequence. That's going to be our f of 1 or a sub 1. Once we find that, we're then going to go back to the idea of if it's arithmetic or geometric by finding the common difference, the common ratio, or the general relationship. And then finally, we're going to write our rule. So for this first problem here, we have the sequence of 4, 8, 12, and 16. We see that the numbers are increasing, and they're not increasing too rapidly, which means it's probably going to be arithmetic. Then we're going to identify what our first term is. Our first term is going to be a sub 1 is 4. Then we want to find our common difference. And again, it's common difference because we're talking about arithmetic. How do you get from a 4 to an 8? Well, you have two options. You can multiply by 2 or add 4. But if I do 8 times 2, that's not going to be 12. We're going to actually have to add. So 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. And so that means our common difference is going to be 4. Once we have those two things together, we're going to put it into the rule for our recursive statement here. So what we'll do is we'll say a sub 1 is equal to 4. And then the rule is, for the next term in the sequence, is we take our previous term, which is a sub n minus 1, and we're going to add 4 to it. And that's going to be the recursive rule for this sequence. You could have done the explicit rule, and the explicit rule would have been a sub n equals our first term, which is, which would be, in this case, 4, plus n minus 1 times our common difference, which is we keep adding 4 on this one. Now, again, like I said, this is recursive, which is what we were looking for. And then this one here is explicit. So be careful when the question is asking if they want you to answer the question as a recursive formula or as an explicit. The main difference between those two is that recursive, you need to know the previous term in order to find the next one. It creates a chain reaction. But for explicit, you can find any term in the sequence just by substituting in the place value that you're looking for. All right, moving on to the next one, we can see that here we are going to be repeatedly multiplying by 2. And we just know that by looking at their numbers and being familiar with it. So that means that our starting value still is a sub 1 equals 4, and our common ratio is 2. To write our recursive rule, our first term is 4. Yes, you always have to define that first term. And then our a sub n, the next term that we're trying to find, is going to be the common ratio times a sub n minus 1. And we know that that common ratio in this problem is actually the number 2. So that would be our recursive formula here. Pause the video and see if you can find out, first of all, whether question number 3 is arithmetic or geometric. Find the starting value, find the common difference or ratio, and write the recursive rule. But I'd like for you to write this recursive rule not with the a and the subscript, but with our function notation. If you're not sure of that, look at yesterday's notes as a guideline. Okay, so first up, our first term in this sequence, our f of 1, is going to be 25. And then you can see here that we are continuously subtracting 5. So our common difference is subtract 5, meaning it is an arithmetic rule here that we're going to be following. So when we write our final answer, I'll write f of 1 equals 25, because remember, you always need that starting value. Then f of n is equal to f of n minus 1 plus our common difference. But our common difference in this case is down 5, so minus 5. And that's going to be our recursive rule. So that's a summary of writing recursive rules from a list of numbers. Now we're going to take it a step further. Now we're going to be writing the explicit formula given the recursive formula. In order to do this, we need to find the first term of the sequence, which is pretty straightforward because it's given to us, find the common difference or ratio, and then write the rule from the general formula. So, looking at this first example here for arithmetic, we see that our first term in our sequence is a -5, and you can see that we are repeatedly adding 7 to our previous term. So if we wanted to write our explicit formula, remember that is given to us on our reference sheet. So it's given with the a and the subscript notation, but it's also as f of n is equal to our f of 1, our first term, plus n minus 1 times our common difference. And in this case, f of n is going to be equal to -5 plus n minus 1 times our common difference, which is 7. Now, you could have your answer written in this format, or if it's a multiple choice type question, they might simplify this equation. So this next step is not necessary, but I would actually distribute, and I would have f of n is equal to -5 plus 7n minus 7, and then I would combine like terms, giving me f of n is equal to 7n minus 12. So that would be an equivalent answer as well. But like I said, if it's just like a part 2 question where they wanted you to write it out, you could leave it at this stage right here. But this stage, it might be the answer in a multiple choice question. We're going to do now the same thing with the geometric formula. So remember, you need your starting term here, and we need our common ratio. So when we write our formula out, again, it is given to us on our reference sheet as a sub n is equal to our first term times r to the n minus 1. And now we'll substitute in the information, so it'll be a sub n is equal to our starting term, which is 1/3, and our common ratio, which is -3 to the n minus 1. And usually this one is not simplified any further if it's a multiple choice question. Now that we've done the basics of recursive and explicit formulas, now we're going to go and do some applications to geometric representations. It sounds a lot scarier than it actually is. So here we have a question that says the diagrams below represent the first 3 terms of a sequence. Assuming the pattern continues, which formula determines the a sub n, the number of shaded squares, in the nth term? Now, when you're first starting this problem, you might be visually overstimulated because it does look a little bit overwhelming with these diagrams. But remember, all we're doing with sequences is working with lists, so let's translate this information into list format. So they're talking about the shaded number of squares, so let's first count the number of shaded squares in each of these diagrams. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the first one is 12. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So really we have the list of numbers of 12, 16, and 20. Now looking at that, it's actually not nearly as bad as what we were thinking from before. You can see here that what you're actually doing to get from one term to the next is going to be adding 4. Since you're repeatedly adding 4, it's going to be either choice 1 or 3. It can't be choice 2 and it can't be choice 4 because of the minus 4 at the ends. Now, the difference between these two is having to do with the subscript notation. So here, see how it says n plus 1? That means it's the next term in the sequence that you're adding 4 to, but n minus 1 is the previous term. That's going to be our answer because remember, when you're doing a recursive sequence, you're always adding to the previous term. So the answer to this question would be choice 3. Pause the video, make sure you really get that down and understand the concept before moving on, please. All right, on to the last question of this video. Here we have another set of diagrams, and it says each square in this pattern has a side length of 1 unit. Imagine that the pattern continues. Record the information for the given figures in the table below, then continue the pattern. So before we can do anything, we need to see what's actually happening within these patterns here. I'm going to use the highlighter to help demonstrate this. So in our first figure here, we have 3 across and 1 down. It looks like that Tetris symbol, that little T shape in the Tetris symbol. So if that's our original one, and we were to retrace it in our next one, you can see that you have added on 1 in each direction. And if I were to do that shape in the next one, you see it's adding 2 in each direction and adding 3 in each direction. So that means that what we're actually going to be doing in this situation is we keep adding on 3. So this figure right here, this figure originally has 3. Oops, let's undo that and do our number here. 3 is the number of squares in this first unit. Then we want to do, this next figure has 3 plus 3, which is 6. Then we have 3 plus 3 plus 3, which is 9. And then 3 plus 3 plus 3 plus 3, which is 12. And you can see that we keep increasing it by 3 on each one of these sequences. So now that we have that information, it says we have the figure and then we also now have the perimeter. Now that's a little different. So for the perimeter, I'm going to calculate that using a red notation. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is the first number if we're referring to the perimeter. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So you can see very clearly here that with our blue numbers, if we're counting the number of squares, you just keep increasing them by 3. But if we keep with the perimeter, to get from a 10 to a 16, we add 6. A 16 to 22, we add 6. 22 to 28, we add 6. So when we're looking at this diagram, even though we have that information with the blue numbers, we want to use the red numbers because it's talking about perimeter. So if our first shape has a perimeter of 10, our second shape has a perimeter of 16, our third shape is 22, our fourth shape is 28, we're going to continuously add 6. So 28 plus 6 is 34, 34 plus 6 is 40, 40 plus 6 is 46, 46 plus 6 is 52, and then finally 58. Now, if we wanted to write a recursive rule regarding this perimeter, it would be a sub n is equal to, or I should say our a sub 1 is 10, so our first perimeter is 10, and then a sub n is equal to our previous term plus 6. That would be the recursive rule if we were referring to the perimeter. If instead we were referring to the number of squares, or cubes, no, squares in this case, it would be our first term has 3, and then a sub n is equal to a sub n minus 1 plus 3. So it depends on how the question is phrased as to which recursive rule we would be using. But because our table is talking about perimeter, that's why I suggest that we use the perimeter formula as our final answer. All right, I hope this information has helped you. Take care, everyone, and goodbye.